Hello, this is going to be a brief demo of Decompiler Tool, which is a new tool coming in FlowStorm 4.7. It allows you to see the bytecode emitted by any form, any Clojure form we compile. So as you can see here, we have the form for quick sort implementation, and on the left side and on the right side we have the emitted bytecode. But it not only allows us to see the emitted bytecode by the compiler, but also by clicking around we can see like which expressions are generating which bytecode instructions, and also the other way around. By clicking on the bytecode we can see the expressions responsible for emitting them. This is pretty similar to the Codeball project that exists on the web for other languages, and I think it's pretty interesting if you are into like tuning the performance or your Clojure programs, or just want to understand what JVM bytecode it's generating. So let's start from scratch. So using it is pretty straightforward. We are going to start a Clojure REPL here with our 113 storm alias. This is going to start REPL with Clojure Storm 113 alpha 4, which is pretty new. From here we just start our UI as usual, our FlowStorm UI. Let's make this a little bit bigger. And here we have our Decompiler tool, a new Decompiler tool. To use it, it's pretty straightforward. We just need to evaluate whatever expression we are interested in, marked with this meta keyword here, which is Clojure Storm collect emitted. This is going to tell the compiler that we want to collect the bytecode as it's emitting it. So we can run that, and as you can see, it automatically displays it on the on FlowStorm. From there on, you can see that it generated a class with a bunch of methods, and you can start clicking around and seeing where this is coming from. You can emit multiple forms. Also, let's say, I don't know, we have like an extra one here, and as you can see, you're gonna get like the multiple forms here, and by clicking them you're gonna see the bytecode displayed, but when you click the other form, this is gonna refresh, so this is gonna be the bytecode for this form. And yeah, let's go into more examples. So here we have our Emacs instance running, connected to a REPL, and our FlowStorm running here. So we can go through a bunch of examples. The simplest thing here, we're going to mark, we are interested in the decompiling in this sum. As you can see here, we can see this is the bytecode emitted, and it's doing like local clearing here. So for each parameter, it's assigning nulls, and so the garbage collector can free these when it's not used anymore. And we can tweak this stuff by changing the compiler options in the Clojure compiler. We can do this from here. For example, we can do disable local clearing. So now when we run this again, we can see that we don't have that anymore. So we are basically pushing our first parameter, our second parameter. We have the annotation, these comments here, and then we are calling numbers add for those, and then adding a third parameter and calling add again. Okay, so yeah, we can change this here. Let's try like a different example here. We have in this case like an if statement, so we can have labels. So here we can see branches. So this is basically grabbing the comparing x to 10 with Clojure numbers less than, and if that's okay, it's gonna jump to label 0, which is here. So if we click here, we are gonna see now we are decrementing. Sorry, this is the else branch, and if it's okay, it's gonna be here on the then branch. So yeah, we can see labels, we can see parameters, names, and we can also see how for like a Clojure function we are generating a class with a bunch of methods, like for a method for initialization, and then this invoke static method where everything happened, that is going to be called from the invoke one. Then we have like a little bit more complicated one here, which is like again a bunch of things, but I wanna, so we can click around and see stuff, but this is already pretty useful here because just as making a bunch of sums, but here we are obtaining this number from a map, and we're obtaining the number by using the keyword as a function on the map. Okay, and if you click here, you're going to see already that this generates quite a bunch of bytecode. But we can try different options here. Let's say we want to access this map by just calling get instead on the map, on the keyword. And when clicking here, we can already see that this less bytecode. This is just loading the map pointer on the stack and then grabbing the keyword, which is a constant for us, and then calling get. Or we can see what happens if we just call the method directly. So here we have like a direct call to a persistent map get on this, and now we can compare them if we want, which I think it's pretty useful. So yeah, we can also take a look at what happens when we are working with multi-arity functions in Clojure, and it's interesting because it generates a class, but then for each one of the arities is gonna generate an invoke static method in the same class. So for the one parameter arity is gonna generate this pair, and then for the two parameters arity is gonna generate this other pair, which you can also see like, well, it's loading A and B and then doing the plus here. So another thing we can try is this here, as you can see, because I didn't mark this to be collected, nothing happened when I evaluated that function. Now we can call this here, and we can see how it's calling a function. So for calling this other function, it's going through the bar. So it's loading the bar pointer, getting the bar root, and then checking it's a function, and then calling invoke. But if we are doing direct linking with our compiler, what happens when we compile this function, it's that it's just doing a call to that function. So it's not going through the bar. So yeah, that's another thing. And then if we are working with exceptions, again we are going to see a couple of labels here, but at the end of the invoke static, we are going to see the exceptions table. So in this case, it's like arithmetic exception. It's basically whatever happens, it's covering the try block if from label 2 to label 4. So it's basically label 2 to label 4. So this is the body. And then if it's an arithmetic exception, it's going to be handled by L0, which is this is L0 thing here, which is this print line, or it's going to be handled by L1 in the case it's an exception. Okay, so we can see like more complex one here where we have like an anonymous function, and it's interesting because we can see, for example, that this anonymous function here, it's generated two things. First, it's generated like a different class. So this is another class which has an invoke. This time doesn't have like the invoke static, just the invoke, and it's being called from here. Okay, it's being invoked from this other function. Yeah, so we can check different things here. In this case, we have like multiple classes being generated by this simple expression. It also works okay with macros. So in this case, we have like arrows, and we can see like this plus 20 is generated basically loaded on the stack 10, 20 and call it add. So this 10, 20 and called add, and then we are adding another 10 and call like minus, and then for the final thing we are just adding a 30 and calling multiply, and then being sure it's a number. And what else? Well, in this case, if we collect, if we are creating a type, you can see here that we are creating a class. In this case, we are creating a type, and we are overwriting the to string from object. And yeah, here we can see. So this is my type we are generating, and it's generating other methods like initialization, and we can also see here the toString we just implemented. And yeah, I think that's all for the basics. Hope people find it useful. Yeah, bye bye.